That was a very good start. Thanks, Neil. That leads very nicely into my presentation. So as Neil said, he spoke about the Earth system model as a whole. I'm going to talk about the atmospheric components, and I'm doing it on behalf of the CCMA Atmospheric Physics Working Group. So yeah, thankfully, Paul and Neil talked about this already a bit, but the slide on the image on the left kind of shows how at the core we have the Earth system model, which is directly linked in together several components to make up the Earth system model, and one of those components is the atmospheric model, which is called CanAM. I have a slightly bigger diagram that actually shows the outer shell of the different applications of ESM. So we have chemistry modeling, regional climate modeling, CANSIPS, and ocean modeling. But yeah, if you look at the atmospheric model on its whole, it's another layer of the onion where we have the atmospheric model actually bringing together of a large number of atmospheric processes through parameterizations that as a whole all brought together kind of model what happens in the atmosphere and tries to simulate it as best we can on a discretized set of grids and time integrations. And so the atmospheric model, as was pointed out, it's been developed at CCMA for a very long time, since the 1970s, 1980s. So it has a very long lineage. And it has a kind of, as it was brought up, it's a kind of unique model in the fact that most of the processes that are being parameterized in the model have been developed either by researchers at CCMA or in collaboration with CCMA. And shown on the right side is just a few of the parameterizations that we currently have in our model that have been developed very heavily or entirely inside of CCMA. So we have parameterizations for gravity waves. We have a dynamics model that is based off of a spectral model currently for the model, but we're in the future going to move to the GEM model, which is an Environment Canada dynamical core. We have our convective scheme that was developed by Norm McFarlane, aerosol schemes that was developed both as a bulk scheme quite a long time ago, and also a newer version, which is based off the PAM approach. We have chemistry that's been developed in-house, cloud schemes that have been developed in-house, a radiation scheme, and a boundary layer scheme. So we have this very interesting model that's built up of a very unique set of parameterizations. And it was mentioned before, and I actually just grabbed a diagram from this paper. So there's a paper by Kuma from last year where they tried to actually look at the lineage of Earth system models participating in CMIP6. And you can see that, as was mentioned, a lot of the models that are currently used in CMIP6 or were used in CMIP6, if they're traced back through their genealogy, you wind up seeing that they kind of come from initial place. Of course, they're going to evolve over time, but they have a common lineage. As was mentioned, the CanAM and CanESM models, they kind of sit out on their own, separate from the rest of the model. So we have our unique components for the ESM as a whole, but the atmospheric model holds its own unique set of parameterizations. So it makes it an interesting contribution to the overall ecosystem of Earth system models that are done globally. So I'm not, my approach for this presentation was not to really delve really deep into the individual processes and parameterizations that we use for the atmospheric model. I've kind of tried to take it as an overview and refer, where possible, to key papers that give you a more in-depth description. So I'm going to step back, actually. So we've been talking about CanAM 5 and 5.1. For the atmospheric side, I want to step it back to CanAM 4, because that was the model we used for CMIP 5. And I would say that that is the starting point for CanAM 5. CanAM 4 represented a very large step in the whole set of physics that are used in the atmospheric model. And it represented a change in resolution from a much more coarse T42 to a T63. And so over time, over the span of several years, we've built on top of that CanAM basis. But if you look at this paper by Knut von Selsen from 2013, it gives a very nice description of the physical parameterizations that were used in the model at that time. We led a paper last year where we described all the iterations and all the improvements that occurred since CanAM 4 and described all the updates in the physical parameterizations as well as the large components. And I'll just mention that CanAM 5.1 is described in the paper by Michael Sigmund that was also published last year. And it includes a relatively modest number of changes, although it was a lot of effort to do them, to CanAM 5 to address some issues that were noted. So just to point out that, the CanAM 4 and CanAM 5, as was described in Neil's presentation, rides on top of underlying sea ice models, ocean models, land models, and couplers that bring them all together. So this is just a kind of like a timeline of what changes were made from CanAM 4 to CanAM 5. Just highlight a few points here. There was a number of changes to the radiation in terms of treatment. We increased the number of vertical levels. We brought in the PAM model, both as the aerosol model itself and as well as coupling it to the radiative transfer. So there's interaction between those two. We updated the land surface model to class. And then we also did an improved treatment of the surface. So that includes bringing in a lake model, a small lake model, treatment of tiling. So in an individual atmospheric grid box, you could have multiple surfaces occurring. So we modified the models and parameterizations to take that into account. And we improved some aspects of our cloud scheme to kind of bring it up to some processes that we felt were necessary. And like I said, this is all described, the changes between these two is described in the papers that I referenced before. For CanAM 5.1, the two biggest changes were, as Neil pointed out, there's two groupings of adjusted parameters. So we have like a P1 and a P2, which represent same physics with different groupings of uncertain adjustable parameter settings that had an impact on one thing was climate sensitivity. And another thing that was not a small task in any way was for the advection of tracers in the spectral model, we use what's called a hybrid tracer, which requires some tuning. And from our CanAM 5 contribution to CMIP 6, we found that there was issues with how dust was being transported in the atmosphere. And so it required a retuning of these hybrid tracers. And that had a significant improvement on how dust was being represented and its transport in the model. I just want to mention, I just talked about the physics. CanAM 5.1 is capable of being run in two main configurations that we typically use it for the experiments. One type of configuration is having it coupled, interacting with the ocean and sea ice, and so everything's brought together, talking to each other. Another one that's used quite often in the atmospheric side of things is that you want to kind of reduce all that complexity so you can actually do simulations where you prescribe the sea surface temperatures and sea ice, but allow the land ocean to adjust. So often you'll hear this referred to as AMIP simulations because that's the initial configurations type of experiments were done in the past. And I'm just showing on the right what you might see, like for our CMIP 6 contribution, we did long simulations with the fully coupled model, which is the kind of bluish line here. But we also did a bunch of similar length simulations where we used prescribed SSTs and sea ice for the duration of the 20th century. So these are two configurations that we typically use the atmosphere looking at it with. And I have to check with Neil, but I don't know if the AMIP simulations are in there, but there should be capability of doing it, at least internally at CCMA. I'll also mention that there are two physical configurations of the model that we use internally. They're not in the verified configurations, like they weren't CMIP 6 experiments that use these configurations, but we use them for development purposes internally. One is that there's a capability in CanAM 5.1 to turn on the PAM aerosol instead of the bulk, and that's an optional configuration. Another optional configuration is to configure the model to run in a dynamical middle atmosphere model configuration. So we'll often call that dynamical MAM. So it doesn't have all the complex chemistry, but it has the higher top model lids and the extra levels and things that allow you to run in the MAM. And just a caveat, like I've probably just said about 4 times, these configurations are available, at least internally. I don't think they were in the list. They weren't in the list that Neil described, but they are developmental versions of CanAM 5.1 that we've used for development within CCMA. So I just want to, because if you do look at the code, you will see those options, and I just want to bring it up to be clear about it. And I just want to finish off just giving a couple of suggestions about where we're going to go, because Neil mentioned CanAM 5.2 is on the horizon, as well as development for CanAM 6. I just want to note that CanAM 5.2 is actually representing a very significant step in the physics in CanAM. We have basically a totally overhauled radiation scheme where we have a new treatment of gas absorption through a new correlated K model. We're bringing in four-stream radiation solvers. We have TKE boundary layer scheme, updates to the deep convection scheme. There are improvements to how aerosols are treated, both for the bulk and the PAM model. And a big piece that we brought in was we brought in the latest classic land surface model, which Vivek will talk about shortly. So that's very right now on the horizon that we're going to start working on that within CCMA to kind of get that model together and adjust it so it's working in the ESM modes. The next step on the horizon is, as Neil pointed out, CanAM 6, which the biggest thing for that will be the switch from the spectral core to the GEM dynamical core, which is a big effort that we're working on right now as well. And I'll just finish off noting that the 2 papers that I referenced throughout my presentation, I'm providing here the entire reference so that you can go find those papers to look at more details. And with that, I will thank you.
Thank you so much for your talk. That was great. Does anybody have any questions? Yeah, Ivy?
Yeah, thanks for that, Jason. I was just wondering where the P3 microphysics fits within the latest updates in CanAM. Is that going to be CanAM 6 then, or?
No, it's going to be CanAM 6.1.
Okay.
Yeah, we're I'll just be honest, we're so focused right now trying to get ready for CMAP 7 that it's taking all of our resources. I will say though, we do have somebody that will be starting at CCMA in about a month, and
Right.
P3 will be his sole focus. That's all he's going to be working on, so it'll make more progress.
Right. Thanks.